Now is
Yes,
it?
yes, yes.
Okay. So create an interface for RBI, like public interface RBI. In this RBI interface, you need to create abstract methods for debit and credit. So public void debit of how much amount you want to debit, that you need to pass it here. So I'll pass the amount at which I want. Suppose if I want to debit 100 rupees, so that I will be passing it here. And one more abstract method, public void credit. So if you want to add any return type also, you can add, no issues. So how much amount I want to credit, that amount I'll be passing it here. So that is the one. And if you want to have any variables, I can have it like int balance. So minimum balance that a bank should maintain. So balance is suppose if the bank has to maintain, I'm giving a rough amount like this. So this is the minimum balance that a bank should maintain. So like this, you create an interface, and in the child class, SBA is the child class, which is going to implement this debit and credit methods. So in this class, so public class SBI, you will have public static void main method. For now, let me leave like this. And how this is going to implement the debit and credit, I'll write it here. Public void debit method, which will access int amount. Here in class SBI, I will define, I'll have balance of the account. So int or float, sorry, double amount can be even floating point numbers. Double balance, account balance. So this is different and this is different. This is account balance. So I'll write AC underscore balance. Sorry, let me be clear. This is double AC underscore balance, account balance, the balance in the account. So whenever you are debiting, the account balance should be reduced, right? So AC underscore balance minus equal to amount. This line means account balance is equal to account balance minus amount. How much amount you are debiting, that amount will be minus from the account balance. Suppose in your account, you have 1,000 rupees. This is the account balance. Account balance is equal to 1,000 and you are trying to debit 100 rupees. Now your account balance will be, new account balance will be account balance minus equal to 100. That means which is the amount. So 100 will be minus from your account balance and your new balance will be 900. So new balance will be 900. The same way for credit also, public void credit int amount. Here what you have to do, account balance plus is equal to amount. So how much amount you are crediting, that amount will be added to your account balance. So we are giving plus. So account balance plus is equal to amount means account balance is equal to account balance plus amount. So this is the shortcut, we can write it here. Minus is equal to, plus is equal to, or multiplication equal to, anything you can write it here. That means account balance is equal to account balance minus amount. Account balance is equal to account balance plus amount. This is the shortcut you can write. Now, these are the two methods, abstract methods we have overridden in the child class. Now we have to call these methods. How we can access these two methods? In order to access these two methods, as these are non-static methods, you need to create an object to this class. So let me create an object to this class. SBI. S is equal, sorry. S is equal to new SBI. This is how I create an object to this class. Using this object, I can call debit and credit. As I have defined it at global level, this what is this variable type? Can someone tell me? I have defined it outside the methods. So what is this variable type? So we have three types of variables, right? Instance variable, class or static variable, and local variable. So what is the type of this variable which I have defined here? Double account balance. Can someone tell me? Out of these three, what is this? What is the variable type? Pratyusha,
Static.
I didn't use the keyword static, right? If I use the keyword static, then it will be static. Otherwise, it is an
Okay.
instance variable. Okay, Pratyusha?
Ah, mm.
So this is an instance variable. So it will be accessible in all the non-static methods. So public void debit is a non-static method. Void credit is also a non-static method. So no need to pass this account balance to this methods. It will be visible globally for all the non-static methods. So I can just pass the amount I want to debit or credit to this methods. That is enough. So S dot debit of 100. If I pass like this 100 will be captured in this amount and it will be debited from the account balance. Now, if I use this credit method, if I want to access this credit method, S dot credit of 200. Now, if I want to print the account balance, system dot out dot println AC underscore balance. What will be the output at this line? What will be the output here? Can someone tell me what will be the output here? So debit I am performing for 100 rupees and credit I am performing for 200 rupees. And initial account balance, let me define it here. Initial account balance is 1000. It is 1000. So double account balance is equal to 1000. Initially it was 1000. And now I'm performing a debit of 100. And after that I'm performing a credit of 200. And after that I'm trying to print the account balance. What will be the balance here?
1100.
Yes, correct. It will be 1100. Okay, the account balance will be the 1100. And what about this int balance? How we can access it? How we can access this balance variable which is created in the interface? You can access it like system.out.println. Using the interface name, you can access it. Or like using this yes also you can access it. Yes dot balance. Using S dot balance, you can get this variable value in this child class. This way also you can get it, or using the object reference also you can get that variable value, and you can write an if condition. If the bank balance, there will be one more. If you want to create one more variable, you can create. If bank balance is less than S dot balance, then there is an like alert or warning, something like that. Otherwise, you are good to go. Bank balance should always be greater than the minimum balance set by the RBI. So this is how you can create an interface and child class and implement the abstract methods. Clear all of you? Is it clear all of you? Okay, the next program we will see. The next one is you will have an array, integer array. Suppose I'll take few elements, 10, 6, 15, 12, 25, 40, like this. I have this array. whatever array it might be. I want to sort the elements, sort in descent order, sort in descending order. Sort these array elements. Now they are placed at random. So 10 is greater than 6, but 6 is less than 15. 15 is greater than 12 and 12 is less than 25. So they are placed in random order. Now I want to place it in descending order. Descending order means the greatest value at the top. What is the greatest value? 40. So 40 will be at the first location, 40, then 25, then 15, then 12, then 10, and finally it will be 6. So this is the descending order. You have to arrange the elements of this array in this fashion. In descending order, you have to arrange it. How you can do it? So I'll take two variables here, two loops here. Int I is equal to 0, I less than array dot length, so a dot length, and I plus plus. And I'll take one more loop here for int j is equal to I plus 1, j less than a dot length, and j plus plus. This is the inner loop. And I'll compare if a of I is less than a of j. Then what you do, you have to perform the swap operation. For that, I'll take a temporary variable. Int temp is equal to 0 for first. Now, to swap, we need a temporary variable, right? We have already seen the logic how to swap two numbers. So now, if a of I is less than a of j, I want to swap those two. So temp is equal to a of I. This is the logic for swapping. A of I is equal to a of j, and a of j is equal to temp. So this is how we write the logic for sorting the elements. Now, how it works, if you want to see, let me show you. Or if you want to try, you can try it as well. Now, this is the I value, j value, okay? And a of I. Okay, we will see how it will happen. Now the I value is 0, initial value of I is 0. What is the length of this array? 1, 2, 3, 4, 5, 6. So a dot length is 6. So this loop will be repeated 6 times. And now the j value is I plus 1. What is I? 0. 0 plus 1 means 1. So j value will be 1. Now what is happening here? If a of I is less than a of j, what is a of I? A of 0. A of 0 is 10. This is a of 0, a of 1, a of 2, a of 3, a of 4, a of 5. These are the array elements. A of I means a of 0, which is 10. If 10 is less than a of j means a of 1, which is 6. Is 10 less than 6? True or false? Is 10 less than 6? False. It is not less than 6. So it will not go into this condition loop. It will not go into this if block. Now the outer loop will be repeated again. Now j value will be incremented. What is the new value of j? It will be 2 now. It will be 2, and again it will come into this loop. It will check this condition if a of I is less than a of j. So what is a of I? It is 10. A of j means a of 2, which is 15. Is 10 less than 15 true? Yes, it is true. Now these two values will be swapped. These two values will be swapped. Now a of 0 will be 15 and a of 2 will be 10. These two will be swapped. See, this condition is true. A of I is less than a of j. That means these two values will be swapped. These two will be exchanged. So the new value of a of 0 will be 15. And the new value of a of 2 will be 10. This is 15 and this is 10. Okay, here it will be swapped. Swap will happen here. Now, the value of j will be incremented. It will be 3 now. The loop will be repeated again. Here what is the new value of A of I? A of 0 is 15 now. It is not 10, it is 15. And A of J is A of 3, which is 12. It will check this condition. Is 15 less than 12? No, it is false. So it will not perform this swap operation. Again, the loop will be repeated. J value will be 4. Now, it will check the condition. A of I is less than A of J. So 15 is 15 less than 25. Yes, 15 is less than 25. It is true. So it will come inside this if block and it will perform the swap operation. So what is the swap operation? So it will exchange this 15 with 25 and 25 will be exchanged with 15. So it will perform the swap operation now. Here it will be 25 and here it will be 15. It will be 25 and it will be 15. Now, the J here also one more swap will be performed. Now, the value of J will be incremented. It will be 5 now. What is the A of 0? A of I is 0, which is 25. Is 25 less than 40? Yes, it is less than, it is true. So again, one more swap will be performed. A of 0 will be replaced with A of 5. So the first element will now be 40 and the last element will be 25. This will be 25. This will be 40 and this will be 25. This is how the first element, the greatest element, the highest element will be placed at the first location. For the first inner loop, for the first outer loop, which is the highest element in all these elements, that will be placed at the first location. So 40 will be placed at the first location, which is the highest element in this array, 40. So that 40 will be placed at the first location for the first iteration of the outer loop. For the first iteration of the outer loop, the highest element will be placed at the first location. Now, the J will be incremented by 1, so it will be 6 and the condition is false. J is less than 6 means false. 6 is not less than 6, so it will come out of that loop. And now outer loop will be repeated. I value will be incremented by 1 and the J value is I plus 1, which is 2. So J value will start from 2. It will not touch the 0th element now. It will compare now it will be placing the second highest element in the second position. So what is the second highest element? 25. So it will place 25 in this location. See how it will place. Now I value is 1 and J value is 2. So A of I, is it less than A of J? Is 6 less than 10? 6 is less than 10. A of I is less than A of 10. So it is true. So it will swap these two elements. So 6 and 10 will be swapped. So 10 will come to this location and 6 will go to this location. Here it will be 10, it will be 6. Now again, here it will perform the swap. The J value will be incremented. It will be 3 now. So 10 is 10 less than 12. Yes, it is true. 10 is less than 12. So again, the swap will be performed. So after the swap, 12 will be here and 10 will be here. So here it is 12 and here it is 10. Again, one more swap here. Now the J value will be incremented by 1. It will be 4 now. It will check the condition again. Is 12 less than 15? Yes, 12 is less than 15. So this 2 will be swapped again. Here 15 will come and here 12 will come. Here it is 15 and here it is 12. Now J value will be incremented by 1. It is 5 now. It will check the first element with the fifth element. Like A of 1 with A of 5. Is 15 less than 25? Yes, it is true. This will be swapped again. So here it will be 25 and here it will be 15. Here it will be 25 and here it will be 15. So this is how the loop repeats, and for every outer loop iteration, the next highest element will be placed at that location. So the next element, now the j will be 6 and it will come out of the loop. The next value of I will be 6, I will be 2. It will point to this location. I will be here itself, and it will compare each and every, it will compare this element with each and every element like this. So if it is less than that, it will sort. Otherwise, it will go like that. It will not sort. It will not sort. So this is how we can sort the array elements in descending order. If it is ascending order, if you want to sort this array in ascending order, just a small change here. Instead of less than, you give greater than. Instead of less than, if you give greater than, it will sort the array elements in ascending order. Ascending order, if you want to sort all the elements, then you can give the greater than symbol. This is the second program which we have discussed. Is it clear, all of you? Can I remove this? Now, the third program is, you have a main string like this. String S is equal to A, B, C, D, 1, 2, 3, 4. And using this string, you want to print the output. Sorry, it is fine. Using this string, you want to print the output as A1, B2, C3, D4. How you can do that? For this also, you need to use loops, 2 loops. For int I is equal to 0. Sorry, I need some more initialization part here. Okay. I is equal to 0. I less than s dot length, string length, I plus plus. Okay. And now for, no need of for, I think. No need of for. 1 second. Okay. And here I'll take 2 variables. The first one is k. Here k is equal to 0. So 2 initializations I have done. For variable I and variable k, 2 initializations I have done. And I is, this condition will be based on I. I is less than, so how many characters are there? That many times this loop will be iterated. Okay. Now if I modulo 2 is equal to 0, if I modulo 2 is equal to 0, I'll take one more string here, string str. This will be my output string. So initially I'll give an empty string here. Str plus is equal to s dot char at of k. And now I'll increment k plus plus. Okay. I'll take one more integer variable, int j is equal to s dot length by 2. I'll explain you. So in this else block, what I'll write, str plus is equal to s dot char at of, I can write j plus plus. So this is the code for this program. Let me explain this. I value, k value, j value, str value. So what is the initial value of I? It is 0. Initial value of k, it is 0. And initial value of j is s dot length. What is the length? 1, 2, 3, 4, 5, 6, 7, 8. 8 characters. 8 by 2 is 4. So initial value of j will be 4. Okay. Now this loop will be repeated 8 times. So because s dot length is 8, it will check the condition here. I modulo 2. 0 modulo 2. 0. What is the remainder when 0 is divided by 2? 2 zeros are 0. The remainder is 0, which is equal to 0. So that is why it will enter into this if condition. Now str plus is equal to s dot char of k. What is this str? Str is an input string which we are going to print in the output. So with the initial value it is blank. Now what we are trying to add to it, str plus is equal to s dot. What is s? A B C D 1 2 3 4. Char at of 0. Sorry, k is 0. So s dot char at of 0 means character at 0th index. This is 0th index, first index, second index, third index, 4, 5, 6, 7. These are the characters at indexes, right? These are the characters at these indexes. Now what we are checking s dot for this string s, character at 0th index. What is the character at 0th index? It is a. So that a will be added to this str. Initially it was blank, nothing was there. Now we are adding it like s dot caret of k. What is the character at, what is the value of k? 0. What is the character at 0th index in this s string? It is a. So that will be added to the str. And again, we are incrementing the value of k. Now the value of k will be 1. Okay. And now this else block will be skipped. This loop will be repeated and the I value will be 1. So the new value of I will be 1. I will be 1. It is less than 8. It will check this condition. Is I modulo 2. What is 1 modulo 2? It is equal to 1. Why? Because 2 when divided by 1. Sorry, 1 when divided by 2, 2 zeros are 0. The remainder will be 1. It is not equal to 0. It is equal to 1. So this if block will be skipped and it will come to the else block. And now what we are doing, we are adding to the str. So what is the existing value of str? It is a. For this a, what we are adding, s dot caret of j plus plus, that is post increment. So what is the value of j? J value is 4. So s dot char at of 4. What is the s dot? So in the string s at character, what is the character at 4th index? The character at 4th index is 1, right? Character at 4th index is 1. So that will be added to the str. So str value initially it is a. Now the new value which we are adding is 1. So the new value will be a1. A1. And the j value will be incremented by 1 because we are doing the post increment. So the new value of j will be 5. Now this loop will be terminated. Again the I value will be incremented by 1. It will be 2. Is 2 modulo 2 0? Yes. 2 modulo 2 will be 0 because 2 when divided by 2, 2 ones are 2, the remainder will be 0. So it will come into this if block. And here we are appending str plus is equal to s dot caret of k. What is the new value of k? It is 1. Character in the string yes. The character at first index. What is the character at first index? It is b. That will be added to str. That will be added to the str. So the previous value is a1. Now the character at first index is b. That will be added to str. Now the k value will be incremented by 1. Previously it was 1. Now it will be 2. Okay, the j value will be the same. J value will be the same. Now this loop will be repeated again. The new value of I will be 3. New value of I will be 3. It will check this condition. Is 3 modulo 2 0? No, it will be 1. So string value will be appended with the character at jth location, j plus plus. What is the value of j? 5. So that the value at the character at 5th index will be added to str. So what is the character at 5th index of the string s? It is 2. So that will be added to the str. So a1, b2 will be added and the j value will be incremented by 1, which is 6. The loop will be repeated. Again, the I value will be incremented by 4. The same way this loop repeats and finally a1, b2, c3, d4 will be printed in the, so that value will be stored in this str and you can print that one as your output. Clear all of you? So this is the string method character at, you can make use of it. String character at, and we are taking two variables k and j. K will start from 0th index. but j will start from the middle index. So from here we are taking one character one time. So first time we are taking the character at kth index, second time we are taking the character at jth index, and we are every time when we are taking, we are incrementing its value. So once kth index, jth index value is taken, again we will be taking the index from k. So that alternate thing we are performing using modulo operation. So alternatively, we are taking one value from beginning and from the middle, so that we can handle using the modulo. I modulo 2 will give you two values, either 0 or 1. So when it is 0, take the start with the starting index. If it is not equal to 0, then start from the middle. So that is the logic which we are using. Clear, all of you? Okay. So these are the programs that we have given in the exercise. Now we'll go to the concept for today. Let me show the PPT. So in our previous session, we have seen the abstract method and abstraction. Now we will see polymorphism, which is the next concept of OOPS. The next concept of OOPS is polymorphism. What is this polymorphism means? Poly means many. The meaning of the word poly means many. I'll say an example. A person can act as a son to his parents, can act as a father to his children, can act as a husband to his wife, can act as a brother to his siblings, and many more relationships. He can act as a niece. So like this, he can act at a particular point of time. He can act as many ways. So this we call it as polymorphism in Java. If a particular method or particular thing, if it is acting differently at a particular point of time based on the requirement, if it is acting as if we can use it for many purposes, then we call it as polymorphism. This phenomenon in Java, we call it as polymorphism. A method, suppose adding two values like 10 plus 15 is an addition operation. 15.5 plus 12.6 is also an addition operation. 10 plus 15 plus 25, this is also an addition operation. So all this comes under a common task called addition. Whatever you do, how many numbers you add, if you add integers or floating or double, whatever you want to add, you can add. So all this comes under a single operation, which is addition. So this kind of mechanism in Java, we call it as polymorphism. That means one thing can be used in multiple ways. One thing can be served in multiple ways, that we call it as polymorphism. Clear? Now, in polymorphism, there are two types. Two types we have in polymorphism. The first one is method overload. We can see in Java, we completely depend on methods. Methods are the tasks, right? So methods only perform the polymorphism, help us in achieving the polymorphism. So there are two types of polymorphism. The first one is method overloading. The second one is method overriding. I think this overriding concept we have already seen. I'll explain you. I'll relate this concept to that. Okay. So method overloading means the same method, suppose addition for two integer variables. The same addition method with for floating variables. The same addition method for n number of parameters, integer, float, whatever you want. The same add, method name will be the same, but parameters will be different. In then that we call it as method overloading. Same method name, but with different parameters, we call it as method overloading. Here, this syntax will be the same. It might be the same, and it might be the different. Here, it may be public static void. It can be public static int. Here, it may be public int or float or double, whatever you want. So this may be different. This may be different or same. That so with that we don't have any difference. This doesn't make any difference. But method names should be the same. Method names should be the same, and different parameters. Then we call it as method overloading. So this we call it as signature of a method. This we call it as signature of a method. Method signature. So method name is same, but different parameters, we call it as method overloading. So whatever we call it here, public static void add of int, this we call it as signature. Public static int add float. This is also a signature. So what is meant by method overloading? Same method name with different parameters, we call it as method overloading. It may be public static void for all these three, public static void. It may be different or the same, but method name should be same with different parameters, and this has to perform the similar activity. Addition operation, addition float, addition of float. For adding float, I'll use this method. For adding integers, I'll use this method, same method name. So this property we call it as method overloading. When it comes to method overriding, everything should be the same. Even there should not be any change in the parameters also. If it is public static void add, then it should be public static void add only. The method signature should be same. Signature should be same. No change. If it is public access modifier in the parent, it should be public here. If it is static, here also it should be static. If it is void, here also it should be void. The method is add, here also it should be add. If it doesn't have any parameters, this also should not have any parameters. In that case, we say this as method overriding. We are overwriting this method. We are overriding this method which is present in the parent. We are overriding in the child class. This concept we call it as method overriding. So in parent, we have one method like public static void add, and which is an abstract method. This should be an abstract method. And that abstract method we are overriding in the child class, override. So whatever method signature is there in the parent, the same method signature should be there in the child. Method signature means public. If it is access modifier is public, here also in parent, if it is public, in child also it should be public. If it is static, here also it should be static. If it is void, here also it should be void. If it is add, here also it should be add. If it doesn't have any parameters, here also in child, it should not have any parameters. So method signature should be same, both in parent and child. Then only we can say that overriding of method is happening. Otherwise, here in parent, if it has one parameter int, and here if you are not adding that parameter int, then we don't call this as method overriding. Method overriding will come into picture only in the case of parent-child relationship. That means the parent can be either interface or abstract class or any other class. Abstract class or any other class. If the child class is child class is either implementing or extending any abstract class or another class, then only method overriding comes into picture. For method overloading, no need of parent-child relationship. So no need of parent-child relationship here. But in method overriding, if you want to override a method, means in parent you have to define abstract method or any other method, non-abstract method. And in child class, you have to override that method. For overriding, everything should be the same. That means the method signature should be same, no difference. So these two will come as under two different types of polymorphism. So this add in parent, we are overriding it. We are achieving that polymorphism in the child class. In the child class. For this parent, there might be any number of children, right? So for this RBA interface, if you see, many children can be there. So whatever, suppose in RBA, we have a method called debit. This debit is overridden in SBI, in Canara or HDFC or ICICI, whatever bank it might be. So the same method debit is performed in different ways in different child classes. So in this way, we are achieving the polymorphism, even in parent-child relationship. So this we call it as method overriding. In SBI also debit will be there, but the logic what they implement may be different, but the same method will be there. Same method signature will be there. Debit in Canara with same method signature, debit in HDFC with same signature, and ICICI also will have the debit with same signature. So this is how only one debit, how many different types we are performing the debit operation in different childs or children of RBA. So this is how we achieve the polymorphism using method overriding. Using method overriding, this is how we achieve the polymorphism. One particular method, debit, differently we are performing it. So in that way, we are achieving the polymorphism using the method overriding. So this method overriding we have already seen. So we have created an abstract method in the interface, and that we are implementing it in the child class. The same method, same signature. That is how we are achieving the method overriding. So even in abstract class, if you have either abstract methods or non-abstract methods, we have seen how we are overriding those methods in the child class. Okay. This is how we can achieve the polymorphism in using the method overriding. Method overloading, we have to see an example. We will see that. If you have any doubts in method overriding, please tell me, because we have already seen that concept, which is called, so this is called compile time. Compile time polymorphism. This is called runtime polymorphism. Why? Because at compilation time itself, the compiler will know to which method it has to go, whether to this method or this method or this method. But this one, to which method it has to go, the compiler will know only at the runtime. At runtime itself, when we are executing the program, at that time itself, it will decide to which method it has to go, whether to the parent or child or whatever it might be. So which method it has to go, it will know only at the runtime. So this we call it as runtime polymorphism, and method overloading, we call it as compile time polymorphism. And one more name for this method overloading is early binding. Sorry, I'll write it here. We call this as early binding, because at compile time only it will get to know. So if we call it as early binding, whereas runtime polymorphism and method overloading, we call it as late binding. At runtime only we will get to know to which method it has to go. So we call this as late binding. The other name for method overloading, we call it as early binding. These are the different names for method overloading and method overriding. Clear, all of you? We will see a program for method overloading. So here, if you see, this is the previous abstract implementation, and this is the abstract class we have discussed. Here we created one abstract method, which is public abstract void demo. The method signature is public void demo. This is the signature, public void demo without any parameters. In the abstract implementation, we have defined the same method, public void demo, same signature. If I write any parameter here, then it will not be override method. It is throwing an error. See, add unimplemented methods. So what is method overloading means the same signature should be present. Whatever the method which is available in the parent, that we are overwriting in the child class. This we call it as method overloading, which is also called as runtime polymorphism or late binding. Using the interfaces or abstract classes, we can make so they will act as parents, and the child class, which is overriding all the abstract methods of interface or abstract class or any other class, that we call it as method overriding. In order to achieve method overriding, interface and abstract class will act as parents, and the child class will be the one which will extend or implement the interface and or abstract class. Is the concept clear? Did you get the picture of what I'm trying to explain? Is it confusing or is it okay? Dinesh, is it clear? Saujanya, Pratyusha, Sajida, Shrija, Pavan? Okay. So this is about method overriding. Let's create for method overloading. Method overloading. Method overloading can be achieved only with one class, no need of parent-child relationship. Okay. Now here let me create few methods. Public void adding integers int a comma int b. So let me print addition of integers. Public void add float, sorry, double. Let me give double. Sorry. Double a comma double b. System.out.println addition of double. Now one more method, public void add of int a comma double b. System.out.println addition of integer and double. Now, in order to access these methods, I need to create an object for this class. Let me create method overloading for this. Sorry. Method loading mo is equal to new method overloading. Using this object mo dot add of. So when you type the mo dot add, it is listing three values here. The first one is for double parameters. The second one is integer and double. Third one is integer and integer. This we call it as method overloading. The same method name with different parameters, that we call it as method overloading. Suppose if I pass 10 and 20.5. So which method will be called? The method at line number 9 or line number 12 or line number 15. Which method will be called? Can someone tell me? What will be the output?
50.
Line number 14. So which line number will be called? So what will be the output? Either
50.
addition or, yeah. So this output will be printed. Let me run this program. So addition of integer and double. Now what if I call mo dot add, add of 10 comma 10? What will be the output of this line number 8? When I write this line, which method will be called? Ten and 10.
10th line.
Yeah. So let me run this program. Okay. So this is what method overloading means. Same method with different parameters, that we call it as method overloading. Same method, it can be performed, same task, if it can be performed in different ways, that we call it as polymorphism. This is method overloading is one of the way how we can achieve the polymorphism. And method overriding means in parent class we define the abstract method, and in all the children it has to be implemented. That method has to be overridden. That way we can achieve that own, suppose like how what we have discussed, this debit, this is the method, this is the task that can be achieved in multiple ways in the children. In this way also we can achieve the polymorphism using the method overriding. So that is what I have given the points over here. So this is one more, this is method overloading or compile time polymorphism or early binding. Same methods with different parameters. Method should be the same but with different parameters. So here we have driver dot in, this will come in Selenium. If you want to perform any wait operation, wait, you can wait in minutes or you can wait in seconds. So 1 minute means 60 seconds. Otherwise, you can give 1 and time minute as minutes, or otherwise you can give 60 and time minutes as seconds. So both are same. The same task, waiting, you have to wait. That can be performed in two different ways, either in minutes or in seconds. So this is how we achieve the method overloading. This we will see in Selenium concepts. Don't worry about this, what and all these things are. Now, what is method overriding or runtime polymorphism or late binding? Same method signature. Same method signature. It uses upcasting. What is upcasting is? Okay. Casting means conversion. Casting means conversion. From low level to high level, if you are converting anything from low level to high level, then we call it as upcasting. From high level to low level, if you are converting, then we call it as downcasting. Otherwise, if you are converting a string to an integer, this we call it as casting. Converting anything, converting from one form to another form, then we call it as casting. See now, what is upcasting means? This is the interface which is a parent. Suppose RBA and child class. This is parent and this is the child. Child is SBI. Okay. Now, what is upcasting? Child, so parent will always be at high level and child will always be at low level. If we are converting a child to a parent, then we call it as upcasting. How we are converting here? So for an interface, we cannot create an object, that we know. So what we do, we create an object for this SBA and refer it to the parent. How we create an object to an SBA? To the child class. So this is like new SBI. So this will be the part that we use to create an object. This is object creation. And what we are doing, we are assigning it to the parent. What is the parent? RBI. RBI, RB is equal to new SBI. So we are creating an object for the child and we are assigning it to RB, which is of type RBI. That means we are converting a child to parent, right? We are creating an object to SBI and we are assigning it to RBI. That, and using this RB, we can access only the methods, abstract methods of this interface, right? So this we call it as upcasting, converting the object from object of the child to object reference of the parent. This we call it as upcasting. Upcasting. Okay. Now you may you may have the doubt how we can convert a string to an integer. Suppose I have a string like this. String s is equal to 1, 2, 3, 4. But I have enclosed in double quotes and I have declared it as a string. So this will be a string. Now what if I want to convert this to an integer? We have a method called integer dot parse int. Integer dot parse int of yes. If you pass this yes here, this yes 1, 2, 3, 4 string will be converted into int. Now int I is equal to integer dot parse int of yes means I is equal to 1, 2, 3, 4. This 1, 2, 3, 4 will not be anymore a string. So string yes is equal to 1, 2, 3, 4 means if you want to convert a number which is in the string format to an integer, you can use this one, integer dot parse int. This we call it as casting, converting to integer, converting a string into an integer. You have lot of casting techniques, like you can convert a float to double. There are a lot of techniques. I will send you a Google link where you can see all those things. So generally casting means conversion, converting one form to another form. Here for overriding, we use the upcasting. So for method overriding, we use upcasting to access the methods that are overridden. So inheritance is an example of runtime polymorphism. We will see what is inheritance. Implementing the abstract methods by the child class is method overriding. This example also, whatever I have given, that will come in Selenium concepts. But as of now, we have already seen that. I have shown the example here of RBI and SBI. This we call it as upcasting. Using this, we can achieve the method overriding. Clear all of you? What is polymorphism? What is method overloading? And what is method overriding? And what is upcasting? Any doubts till now? Is my voice audible and the screen visible?
Yes.
Okay.
Yes.
Okay. So we have seen what is method overloading and method overriding and what is upcasting in previous session. So till now, if you have any doubts, you can ask me. So did anyone get a chance to try that exercise program? Like to find area of a rectangle, square and triangle. Using method overloading. So area of a triangle. So method, what is the method? Area. Area will be the same, but parameters will be changing. So for rectangle, you will take two parameters, which is length and breadth. For square, you will take only one parameter, which is side. For triangle, base into height. Now you need to calculate the area of these three. The method will be the same area which takes one parameter int L comma int B. This is for rectangle. System dot out dot println. Area of rectangle is L into B. Okay. Now, area of square, it will take only one parameter int side. We will print the output as area of square is S into S. Is it the triangle or what? Triangle? Base into 5. Mm. Did they give a triangle or a circle in the program? Exercise program? Don't think. Okay. For now, you know this triangle. So if you want to calculate the area of a rectangle, area of a square, the method names are same, but parameters are different. So in main method, public static void main, this is the main method. So if you want to calculate the area of a rectangle, you can create an object for this object for this class, object dot area, and you can pass two parameters like 10 and 5 like this. So if I call this if I give a call like this, which method will be called? Either first method or the second method. This method will be called because the length is 10 and breadth is 5. So two parameters are there, so this method will be called. If I want to calculate the area of the square, then I will call object dot area of only 5. So one parameter I'm passing, so it will, then I call this one when I use this line, the second method will be called. So if you want to calculate the area of the triangle, also take the area, but just give a small difference between the parameters. So first base you can take it as an integer, and height you can take it as double height. So here you can write system.out.println area of triangle is you can write 1/2 into base into height. So this is what you can print. So if you want to call this method, you can write object dot whatever object you created for this class dot area of the first parameter will be integer, so I'll pass the base as 10. The second parameter height is in double, so I'll pass the floating value. Suppose 5.2 something like this is the height. So this is how we can call these three methods. The same method name area, but with different parameters. Different parameters. The first area method is taking two parameters, which is length and breadth, and both are integers. The second method is area, which takes only one parameter, that is integer parameter. The third method area will take two parameters. The first parameter is of type integer, the second parameter is of type double. So this is how we achieve method overloading. Same method with different parameters. Method overloading. What is the method here? Area. Different parameters we are passing. So this we call it as method overloading. So this was the exercise program which is given yesterday. Now we will see the two more concepts which are pending in OOPS. Those are inheritance and encapsulation. So inheritance means this is the next OOPS concept, which is inheritance. Inheritance means acquiring the properties from the parent. This is the parent class and this is the child class. If you are acquiring properties, if the child is acquiring properties from parent, this phenomenon we call it as inheritance. Inheritance means acquiring or getting the properties, acquiring the properties by the child from parent. This property we call it as inheritance. In what way the child class is getting the properties from the parent? Suppose my parent class is an interface. In interface, we define all the abstract methods, right? In interface, we define only the abstract methods. This will act as a parent. In child class, can we ignore these abstract methods? Can we ignore these abstract methods? Can we, if we don't implement these abstract methods, will it work? No. It has to get all these properties. It has to implement all these properties. All this abstract method the child class has to implement. The child class has to implement all these abstract methods, which are specific to this parent. So this parent is having all these methods. When the child is implementing this interface, then it has to implement all these abstract methods. Implement all the abstract methods. All abstract methods of the parent. So in this way, the child is acquiring the properties from the parent. The child is acquiring properties from the parent. So apart from these abstract methods, can it have its own methods? Yes, it can have its own methods also. So this property of acquiring the features from the parent in the child, we call it as inheritance. This is the concept of inheritance. Inheritance means getting the properties from the parent. A child getting the features from its parent. That property we call it as inheritance. This we have already seen by using the upcasting. The parent can, using the upcasting concept, parent can have access to all the abstract methods in child. So we have seen what is an upcasting also. So for child, you define an object. So suppose RBI is the parent and SBI is the child. For child, you define an object. How we can define new SBI? This is object creation. If you are assigning it to a parent, what is parent? RBI. RBI, RB. This is object. So this we call it as upcasting. From assigning the child object to the parent, from low to high you are assigning, so that we call it as upcasting. Using this upcasting object reference, so this we call it as RB is object reference. So RB dot whatever abstract methods are available in this interface, and those are implemented in the child class. So to all those methods, the parent will have access. The parent will have access to all the abstract methods in the child class. So in child class, whatever abstract methods are implemented, all those can be seen by this parent. This can be achieved using the upcasting. You can achieve that using the upcasting, right? So this is the inheritance. We have already seen this concept. So if you are able to understand interface and abstraction, then it will be easy for you to understand the next concepts like inheritance or polymorphism. Those will be easy for you. So we have already seen this inheritance. What is inheritance before only? Just we are giving definition for inheritance. Inheritance means inheriting the properties of a parent class by the child class. One example is code reusability. So whatever code is there, abstract methods are there in the parent, that we can reuse it any number of times. So we can, like in all the child classes, the same abstract method can be used. So code reusability can be achieved using the inheritance. So you can write the code once in the parent and you can use it in all the children any number of times. So that is one importance of inheritance. I have given one example here. Utilities like taking the screenshot. This we will be discussing when we are discussing the selenium. Okay. So the next feature is it uses extends keyword to implement the methods of the parent. It can use extends or implements. Both are fine. So implements we use in order to implement all the abstract methods of an interface. Extends keyword it can use to implement all the abstract methods of the abstract class. So it can use either extends or implements. One another example of inheritance is runtime polymorphism. So in order to override, like, what is runtime polymorphism? We have already seen runtime polymorphism means method overriding. Runtime polymorphism means method overriding, right? Method overriding. Why do we override? This is the parent class. This is the child class. So in parent, we have abstract method or a normal non-abstract method. So anything we can have. So initially, whatever is there for abstract method, there won't be anything. For non-abstract method, there will be body. And in child class, I'm defining this, I'm implementing all the abstract methods. So implementing all the abstract method means whatever is there, whatever empty content is there, that will be overridden here. For a non-abstract method, so whatever body was there previously, it will be overridden. It will be overridden. Everything will be overridden. So this we have discussed yesterday. So this overriding the methods of a parent, overriding methods of a parent, we call it as runtime polymorphism. Runtime polymorphism or method overriding. Or method overriding. So method overriding you can do only if the two classes have parent and child relationship. Method overriding can be done only if the abstract class and child class have the relationship of parent and child. Only parent and child relationship. If two classes have parent and child relationship, then only method overriding is possible. So what is parent and child relationship? Which is inheritance. Inheritance means acquiring the properties of parent and in child class. So you can achieve method overriding only if inheritance concept is there. If inheritance is not there, then you cannot achieve method overriding. So that is the dependency between the method overriding and inheritance. So we have seen an example here. Runtime polymorphism is an example of inheritance. So only if you have inheritance concept, then only you can achieve this runtime polymorphism. Clear all of you what is inheritance? This is not a new concept. Inheritance is not a new concept. You have already seen this one. If any class is extending or implementing any other interface or abstract class, then inheritance comes into picture. That means it has to implement, it has to acquire all the properties from the parent. The child class has to acquire all the properties from the parent. Thus, that feature we call it as inheritance. After once the parent and child relationship is established, then it has to override all the abstract methods. So that is called method overriding, which is runtime polymorphism. So try to get the difference between these two, method overriding and inheritance. Any doubts in inheritance concept? This is not a new thing that we are discussing. Already we have discussed this one. Okay. Now we'll go to the encapsulation. What is encapsulation? Encapsulation is the next OOPS concept. Binding data members and defining getters and setters to access data members. Generally, encapsulation means, in English terminology, it is hiding. Hiding. Why we need to hide the data? Suppose I'm not hiding any data and I am showing it to everybody. Then what will happen? Everyone will use my code, will use the logic which I have used, and they'll come up with a new version and say, I have developed this one. Then there is no word of copyright. Then there is no word of copyright. So we have to protect the code and logic which we have developed. We have to protect our code and logics, whatever we have developed. So for that, we need to hide it from others, outsiders. That can be achieved by the concept called encapsulation. We have to hide our data. We have to protect our data from outsiders. That concept in OOPS, we call it as encapsulation. Parent and child relationship, we call it as inheritance. Parent child, we call it as inheritance. Method overriding, method overloading, we call it as polymorphism. So if a task can be done in multiple ways, then we call it as polymorphism. The two types are method overloading and method overriding. Next, abstraction means giving a brief introduction, brief understanding or introduction, understanding of a class, what it is doing, of a class on what it is doing. This we call it as abstraction. This can be achieved by interface or abstract class, which will act as parent, and the child can be any other class. So these are the four different main concepts of OOPS. The first one is abstraction. What is meant by abstraction? Which gives brief understanding of a class, what it is doing. So so you can achieve these things by interface or abstract class. An interface also gives brief understanding of what the child class is going to do. And also the abstract class also will give you basic understanding of what the class is going to do. And when you use the keyword extends or implements, then a relationship between the interface or abstract class or any other class and this class will become parent and child. There establishes a relationship between those two things that we call it as parent-child relationship, and that concept is called inheritance. Okay. Once the inheritance is once the parent-child relationship is established, then what we do, we can do We can do either method overloading does not need parent child, but method overriding, it needs this parent child relationship. So once the parent child relationship is established, you can implement all the parent class stuff in the child class. So what and all parent has, all those things can be implemented again in the child class, can be overridden. So parent has some properties like whatever you want to say, debit or something, whatever you want, the parent has some properties. All those properties can also be there in the child class, can also be there in the child class. It can override whatever content is there in this parent class. That content can be overridden, can be rewritten in the child class. So that property we call it as method overriding. Once overriding and everything is completed, we need to hide our data. We need to hide our data from outsider. That can be achieved using the encapsulation. So got the difference between all these four main OOPS concepts? Okay, so how can we hide the data? In order to hide the data from others, so we have already seen one concept called access modifier. What are data members here? Data members are nothing but variables, methods. Okay, so these are the data members. So generally we take variables only in encapsulation. So variables will be the data members here. So what is binding? Binding means combining. Combining data members. Data members are nothing but variables. Combining variables and use the getters and setters to access these data members. So all these data members will be in a class. So in a class ABC, it will contain all the variables. Suppose int A, float B, like this. So these are the data members. And these data members can be accessed using getters and setters only. What are these getters and setters? Setters means these are the methods. Getters and setters are methods that will set a value to these variables and it will help us to get the variables. Setters will help us to set the values to these variables and getters will help us to retrieve the values of these variables. So these are also methods. Getters and setters are also methods which will allow us to set and get the values of these variables. So how can we do that? So setters and getters, it will be like this: getter of int A. Sorry. I'll show you how it will be looking like. The getters and setters will be similar to methods. Those are methods only, which will help us to set and get the values. Now, how can you say by doing this, how we are hiding the information? How we are hiding the information? By just creating the variables and generating getters and setters. I will make these variables as private. If these variables are private, those will be only visible within this class. Outside this class, these variables will not be visible. The scope will not be there. You cannot access either this A variable or B variable outside of this class. But we have getters and setters, right? These getters and setters will be public. These two methods, setters and getters, will be public. So outside this class XYZ, if I want to get this value A, I can just use getter. I can call the method getter method for this variable A and get the value in this class. If I want to set any value to this variable A in this class, but it is a private, you cannot access this value directly. But how can I do that? I can use this setter and set a value for this private variable A. So the methods like setter and getter method will be public, but these variables will be private. So why we are making it private? In order to hide this information, we make this variables as private And we use getters and setters in order to access these variables outside of this class. Outside of this class, if you want to use these variables, I can use setters or getters. Suppose I don't want to set any value. So I'll skip this setter. I just want getters. I'll use this getter. Generally, if you want to make it as protected in order to hide the information, we won't provide any setter access. Don't we know we do not provide any setter access. We just allow them to read the data, to get the data. We will not allow them to uh, like set any value to this variable. Setters will not be allowed all the time. But we generally, if you want to provide any read access, if you want to provide any read access, what is the variable value, then we provide getter access to them. So we'll see how we can create these variables private and how we can generate getters and setters, and how using these getters and setters, how we can access that private variables outside of the class. Okay, we'll see an example. I don't want to use public static void main because here I want to generate only getters and setters for the private variables. So encapsulation, demo. Let me finish. So I didn't create any public static void main because I don't want to execute this class. So here I'll define few private variables, private int a, private float b, and private string yes. So these are the private variables which cannot be accessed outside of this class, right? So outside of this class, I'll not be able to access these methods. Now, I will generate getters and setters for these three variables. How I can generate? Just select those variables. So as how I have selected it, right click, you will have an option to generate getters and setters. So once you right click, you will have this source. So if you go to the source, here you have a method called generate getters and setters. Generate getters and setters. So if you click on that one, it will ask you for what and all variables. So you have defined three variables, A, B, and S. So for what and all variables you want to generate getters and setters. So if I select all these three will be selected. So for all these three variables, I want to generate getters and setters. So by default, the access modifier for this getters and setters will be public. By default, it will be public. Okay. So where it want to insert all these getters and setters, it is showing after A, but I want it after yes. So after this yes variable only, I want this getters and setters. So you can select all these things, whatever you want. Okay. And you can click on generate. See what will happen after this thing. See all these getters and setters, they are public. They are public and these methods can be accessible outside of this class. Okay. So what is this getters? Getters will start with get. Get is the keyword that will start. Get A, get B, get yes. So these three are getters. So what will they return? They return the variables. So get A will return A, get B will return B, get yes will return yes. So this will return the variables. That means wherever this method is called, to that place, it will return the value A. And what is this set is doing? Setters. These are setters, right? Set A, set B, set C. So this will set the value of these variables. Variables which are defined at line number 4, 5, 6. To these variables, it will assign the value. What is the value that it is assigning? The parameter which is passed here. That value will be assigned to the variable which are declared at line number 4, 5, and 6. So it can be like this also. Int AB is equal to AB like this. But why we are using this dot A? This dot A, this we already seen, the object which it is calling. So the object which it is calling, that we call it, that can be stored in this. This is a keyword which will hold the information of current object which is calling this method. So that is why whatever the object is calling this method, set A, that information will be stored in this. Okay. To that, the A value of this class, we are setting it as AB. AB is what is the value we are passing it here. So this is the first part we have done. Created a private variables, 3 private variables, and 3 getters and setters we have declared here. The get will return the values of these variables and set will set the values for these variables. Now we will start with another program which will ask access to these methods. 1 minute, let me create one more class. Okay, for this class, I'll have this public static void main. Okay, now what I will do, I want to access the getters and setters of this class. How can I do that? First, I have to create an object to this class. Encapsulation demo. For that, I need to create an object. How can I create encapsulation demo? Ed is equal to new encapsulation demo. This is the first task. I have created an object to that. Once the object is created, using that object, I can access all these methods. See, get A, get B, get yes, set A, set B, set yes. So you can access all those things. If you want to get the variable value A, you can use this method. If you want to get the variable value of B, you can use this. If you want to get the value of yes, string yes, you can use this method. And if you want to set any values to these variables, so you can use these 3 things. Set, if you want to set value for A, you can use this method. Set for a value for B, you can use this. If you want to set a value for string S, you can use this. So first we will set some values, then we will get those values. Okay. I want to set value for A, which will accept integer parameter. So I'll pass 10. So I'm assigning value 10 to variable A. Now ed dot set B, which will accept floating variable, floating point variable. So I will assign 5.5 to B. Ed dot set of string S. I want to pass string value to S. So I will pass hello. Now, okay, it should be double. Sorry for that. It should not be float. Here it should be double. Here also I'll modify it as double. Okay. Now this is the value of A set to A. This is the value set to B. This is the value set to S. So these are the 3 private variables A, B, and S. And these are the values we are setting. Now if you want to get that information, system.out.println, this is the value of A. Then you can use the same object ed.get. You can use get methods now. System.out.println. This is the value of B. ed.get. System.out.println. This is the value of yes. ed.get. Yes. Now if I run this program, it will print 10, 5.5 and hello. So whenever you call this set A method, it will go to this set A, and whatever value we are passing, that will be assigned to this variable. The same way, if you are calling set B, whatever value we are passing, that will be assigned to this variable, B variable. The same way, whatever value we are passing for set yes method, that value will be assigned to this string. Okay. When you are calling this getters, it will return those values. Get A will return A value, get B will return B value, get S will return S value. Now, if I run this program, So the value of A is 10, the value of B is 5.5, and the value of S is hello. Now, this is the basic thing to in order to set and get values. But what if I want to do some changes here? Suppose I'm passing value 10 to this method, but what I want to do internally is I want to multiply, I want to do some calculations here, like into 2 divided by 5 plus 4. So whatever calculations I want to do, I will do it, and I want to return that value. I want to set this value. So this is the calculation I have done now. Okay, A, B, whatever value I'm passing, to that value I'm performing this arithmetic calculation, and that value I am setting it to A. See here I am passing 10. To that 10, I am doing certain mathematical calculation in this in encapsulation demo class, and whenever I will get that calculation part. But that what the calculation is going on, I will not be aware in this class, right? So it returned 8 now. I am passing a value 10, but I am getting 8 for the A value. So this is how we hide the data. We hide the data, like what we are doing. So here you assume that this part is not visible to the user. So whatever calculations I want to do, I'll do it here, but that is not visible. Here they will pass some values and get the values. But what is the logic implemented inside this methods, that will not be known. That will not be known. They can do any sort of calculations here. So I can do for string also. I can append something here and send. So whatever I want to do, I can do it here. But this part is not visible to the user. What I am performing here, what I am doing arithmetic calculations, or what and all I am doing in this class, in this getters and setters, that is not aware for this program. For this program, it is not aware. So it will set some value and it will get some value. Only that part we will be doing. So one best example I can say, let me run this program. So see, hello world. I gave hello, but the value returned is hello world. I gave 10 for A, but it is returning 8, right? So one example I can say for encapsulation is, suppose you have completed your exams and you are waiting for results. So if you are searching it online to get your results, what and all details you need to fill, this is the form that you need to fill. So you need to fill your hall ticket number, or so some details will be there, right? So you'll fill like, I'm just giving an example, like the college you have taken the exam. So these details it will ask you to fill. Okay, and there will be a button called submit. So once you fill all these details and click on submit, it will show you the details, how many marks you have achieved and what is the percentage. So all these details it will show you based on your hall ticket number or college or whatever year. So it can be year of your examination. So all these details you will fill it here and you will click on submit, and then it will show you all the details of your marks, details of your subject, percentage, how much percentage you have achieved, everything. Now, whatever you provide the data over here, that will be setters, that will access setters. So these values will set to the hall ticket, college and year. Okay, these are the setters. This will act as setters. And now based on this information, whatever you are setting, once you click on submit, we don't know what is happening internally. It will show you all the details, all the marks details, like in so and so subject you achieved this mark, so and so subject you have achieved this mark, your hall ticket number is this. So it will publish some data here. So those are called getters. So those will get based on the setters, whatever values you are setting. It will perform certain calculations internally. It will have some logic internally. Internal logic will be there. So based on that logic, it will get some values. It will publish some values here. So this we call it as getters. So using getters, it will publish the data. It will get the value of so and so subject, so and so. Based on this hall ticket, it will publish the data. So this is how. So we are hiding this logic. Whatever logic is there, how it is displaying everything, it that will be hidden. That will not be shown. Only when you give this information, it will ask you some data to enter. Based on that data, it will display you the content. So this is how, but we are not showing any information. We are hiding the data. So this can be achieved by using the setters and getters. These are the significance of setters and getters. It will get the data and publish it in the UI, where you can read all your information. Clear? And one more example, I can say, like daily you will be doing a lot of things. So here in this paint only, you can have a lot of options. When you are clicking this one, it is performing some activities, right? So how it is performing, we are not aware of it. How it is performing, we are not aware of it. Internally, there will be some logic. Internally, they have written some logic to perform all these things, but we are not aware of what it is happening internally, right? Okay. So what is happening, we are not aware. We will just click on this, we are getting this activity. The logic, we are hiding it. The same way, using encapsulation, we will be hiding the logic, but we will, by how we are hiding the logic? By making these variables as private and generating the getters and setters. By generating getters and setters for these variables, we are making it as, we are making it hidden. How we are accessing this data? Here, we can access those data by using the setters and getters, and internally what and all logic here we have used, that can be hidden. That can be hidden from the user. They will not be aware of this. Now, have you got the concept of encapsulation? How we can hide the data and get or set the data members using the getters and setters? Any doubts in this concept, encapsulation?
Encapsulation is mainly hiding the data only.
Yes, mainly to hide the data.
Okay.
Here we are achieving it using the private variables. We create private variables and we use the public getters and setters. Okay. So in setting and getting whatever you want, you can do it. Like it is up to you how to hide the data. How to you want the logic, you can implement it yourself. But you will be setting some, you will ask the user to set some values and get some values. Internal logics can be hidden.
We take only private only variables.
For variables, it should be private. Because if that variables are allowed to access outside of the class, then what is the use of that getters and setters?
Okay. So we take the private variables, it should be must, right?
Yes, that is a must.
A
By
rule.
private. If those are not private, they can be modified outside of that class, right?
Okay.
So then there is no scope of hiding the data.
Can you go to the program once?
Okay. Yes. This one or this one? Which program?
This one only.
Okay.
Here public int get a. Get a means we are taking the variables.
Yes, get variables, getters. No need to write all this. This can be automatically done by Eclipse. Select the
Okay.
variables which you want to generate the getters and setters, right click,
Mm.
go to source, generate getters and setters. So
Yes,
if you
yes.
don't want to allow any setter, it is not mandatory that for each and every variable you need to have get and set. It is not
Okay.
mandatory. So if you don't want for this variable to set any value, if you don't want to allow the user to set any value for this variable, you can remove this. It is not mandatory. You can, so then this variable, A variable will have only read access. No one can have the write access to that. So whatever is the initial values for this variable A, that will be final. So here, if I define A variable value as 10, only you can have get access. You cannot modify this variable. So that is also possible. It is not mandatory that each and every variable should have getters and setters. So that is up
Okay.
to the, like, so who and all want to design it, how it want to be, then it is up to them.
Okay. Suppose I take the only private variables.
Hmm.
I won't take the public. So it will automatically will take like source and getters and setters.
No, automatically it won't have to. You have to generate these methods. Then
Public. Right?
using these methods, you will be able to access them.
Mm-hmm.
An object for this class and generate this and access these
So,
methods.
we initialize all right private variables and public variables.
No, variables cannot
No.
be public. Getters and setters will be public.
Okay. Okay, fine.
Others, any doubts? So today we are done with the OOPS concepts. From the next session, we'll start with the next Java concept, which is collections. If you have any doubts in this till now, whatever concepts we have discussed, you can ask.